Hello everyone, I am Nitin Reddy. My topic is about lens antennas. It is an antenna which consists of electromagnetic lens with feed. It converges spherical wavefront into planar wavefront and planar wavefront to focus at feed. It is typically thicker, heavier and more difficult to construct. It has one advantage, one reflector antenna blockage is not happening. And the lens antenna is a three-dimensional electromagnetic device which has refractive index other than unity. This antenna is smaller to glass lens used in optical domain. Following are the functions of lens antenna. It generates plane wavefront from spherical. It forms incoming wavefront as it focus. It generates directional characteristics and it used to collimate electromagnetic rays. It controls aperture illumination and a construction and working of lens antennas. If a light source is assumed to be present at a focal point of lens, which is at a focal distance from the lens, then the rays get through the lens as collimated or parallel rays on the plane wavefront. The rays that pass through the center of the lens are less refracted than the rays that pass through the edges of the lens. All the rays are set in parallel to the plane wavefront, and this phenomenon of lens is called its divergence. And the same procedure gets reversed if a light beam is sent from right side to left of the same lens. Then the beam gets refracted and meets at a point called focal point at a focal distance from the lens. This phenomenon is called convergence. And the ray diagram represents the focal point and focal length from the source to the lens. The parallel rays obtained are also as collimated rays. In the above figure, the source at the focal point at the focal distance from the lens gets collimated in the plane wave form. This phenomenon can be reversed, which means the light if sent from the left side gets converged at the right side of the lens. It is because of this reciprocity. The lens can be used as an antenna as the same phenomenon helps in utilizing the same antenna for both transmission and reception. The principle of lens antenna. Principle of lens antenna. This figure depicts dielectric lens antennas as shown in the converted into plane wavefront by dielectric lens. It is also known as delay lens antenna due to fact that outgoing EM rays are collimated and delayed by lens antenna. And it depicts working operation of lens antenna as shown. Feed antenna is used at a focal point of lens. The two different modes of lens antennas are shown vice versa, transmit mode and receive mode. As shown in the transmit mode, diverging rays are collimated which forms plane wavefront after they are incident on a lens and have some out of it. Collimination occurs due to refraction mechanism. It occurs in the lens with refractive index of less than 1. As shown in receive mode, the parallel rays converges to a focal point after they have passed through lens due to refraction mechanism. And lens antennas is used along the point source, but practically on antennas are used at focal point. In the image of the model of lens antenna is shown. Here is the image we can see lens antenna. To achieve the focusing properties at higher frequencies, the refractive index should be less than unity. Whatever be the refractive index, the purpose of lens is to straighten the waveform. Based on this, the E-plane and H-plane lens are developed, which also delay or speed up the waveform. While transmitting, the lens is placed in such a way that the feeding antenna is located at its focal point. This way we get collimated or parallel rays at the output of lens. The feed is usually an antenna that generates a spherical waveform or an antenna array that produces a cylindrical waveform. While receiving, when the incident rays strike the lens, they get refracted and get converged to a focal point where the receptor is located. These types of antennas are used for high frequency applications require wide bandwidths. There are two main types of lens antennas. First one is dielectric lens antennas or delay lens antennas and metal plate lens antennas. Dielectric lens antennas. are those where the traveling waves are delayed by lens media. The lens in this case is usually made up of polystyrene or lucite and polyethylene. This type of antennas are usually used in microwave and wave frequencies as per frequencies less than 3 GHz. They become heavy and bulky. Here the diagram of dielectric lens antennas. And second one is metal plate lens antennas. In this type of lens antennas, spherical wavefront is converted into plane wavefront. But here outgoing wavefront is speeded by material of lens. Here this figure depicts metal plate lens antenna. In this type of lens antenna, spherical wavefront is converted into plane wavefronts. But here outgoing wavefront is speeded up by material of lens. And advantages about lens antennas. The following are the advantages of lens antennas. In lens antennas, speed and feed support do not obstruct the aperture. It has greater design tolerance. Larger amount of wave than a parabolic reflector can be handled. Beam can be moved angularly with respect to the axis. And disadvantages are lenses are heavy and bulky, especially at lower frequencies, and complexity is design costlier compared to reflectors for the same specifications. And its applications used as wideband antenna and especially used for microwave frequency applications. The converging properties of lens antennas can be used for developing higher level of antennas known as parabolic reflector antennas, which are widely used in satellite communication. Thank you.